I'm really excited to talk about some of my results for my dissertation work at UC Riverside. And if you only remember one thing from this talk, remember the title. That's the main result. Time since fire impacts chaparral post-fire restoration success and seed bank recovery. So when we think about restoration, there's a couple key questions to consider, including where, when, and what to restore. And all of these are dependent on the restoration goal, such as restoring for a specific function or a vegetation type, or even a population, such as for rare plants. When restoration is needed, identifying the factors of natural recovery and how they interact and inform questions for restoration is an important first step. And so for chaparral, there's a couple key things. Solar insolation can differ across aspect types, resulting in cooler weather conditions on northeast aspects that typically recover faster compared to southwest aspects that are hotter and drier and recover slower. And for our post-fire regeneration strategies, again, used to classify how species grow back after a disturbance, including our resprouters that survive the fire and regenerate from stored energy, and our obligate seeders that die from the fire but regenerate by seed banks. And then finally, we have the fact that seed banks can indicate when natural recovery can actually occur. And this is, again, especially really important for our obligate seeding species that rely on seed banks for population survival. So identifying which of these factors is compromised when recovery is low is really key to then target in our management actions. And when we think about where to restore, we think about, or we know that increased fire frequency in a given area can have detrimental effects leading to a reduction in recovery. And this reduction in recovery is really driven by time since fire, or the time between fires, or the time since a fire occurred in which recovery can actually ensue. And so this shorter time since fire is a driving mechanism for why recovery is reduced in these repeatedly burned areas and can threaten obligate seeding species that take a long time to reach maturity and set seed. So assessing seed bank recovery can be used to identify areas of low recovery and where restoration might actually be needed. Repeat fires before a seed bank is replenished can degrade recovery in terms of abundance and diversity of the seed bank, as shown here. But when is the seed bank replenished to a level that will actually provide sufficient recovery? For when to restore, when active restoration is needed, it typically occurs many years post-disturbance due to long funding processes and planning, but this time delay can pose a serious problem when the post-disturbance environmental conditions suitable for establishment change. And the initial post-burn environment has a high input of resources from ash and light availability, which is rapidly utilized and depleted in the first few years post-fire. So planting at a longer time since fire may have less suitable environmental conditions. So therefore, assessing how time since fire impacts planting success is a key step to improving restoration efforts. When we think about what to restore, when natural recovery from the seed bank is not adequate, active restoration can use seeding or replanting with saplings to add propagules to the system. Sowing seeds has largely been unsuccessful for woody species due to drought and competition with invasives, leaving outplanting as the recommended restoration method for chaparral. And outplanting is costly, it's time intensive, and still has relatively low survival rates, especially in these drier systems, creating a need for improved recovery or improved outplanting establishment techniques. And one method is to use a trait-based approach to select species mixes for different resource and growth strategies based on restoration goals. And this is typically used, or we typically use an acquisitive to conservative spectrum of resource use when we think about this. And the acquisitive strategy typically has a higher resource uptake, higher growth, and is not as drought tolerant. And the opposite is true for the conservative strategy. But it's unclear how these strategies actually influence survival. And to link this back to the restoration goals, resource use strategies can be chosen for our different restoration goals and conditions. And some examples of this is if overcoming dry summer is limiting survival, choosing the conservative or drought tolerant strategies might be recommended. But if preempting invasive species establishment is needed to reduce competition and improve survival of planted species, then choosing faster growing or even a high diversity species mix might be recommended. And this leads me to my research questions of how does time since fire influence the proportion of seed density recovery relative to mature, unburned seed banks? How does restoration timing, specifically that time since fire piece, influence restoration, planting establishment, and survival success? And finally, how does trait-based communities influence restoration success? So to test these, we set up 2 studies in the Angeles National Forest. We worked in the Powerhouse burn scar that burned in 2013 and the lake fire that burned in 2020, creating a nice time since fire gradient. And we first tested how time since fire influenced that proportion of seed density recovery relative to mature unburned seed banks that we sampled nearby outside of these burn scars. And so we collected soil cores at all these different locations on both south and north facing aspects to get a topographic gradient as well. And then we grew these in a greenhouse and also sorted the seeds by sieving the soil and picking out all the seeds. And I'm going to show the data on the seed sorting today. So to orient to this figure, the x-axis is our time where the lake fire was sampled 1 year post-fire and the Powerhouse 8 years post-fire. The y-axis is a recovery response ratio, where anything below 0 indicates that recovery or indicates less recovery compared to the mature reference seed bank. So we found that there was about 60% less recovery relative to mature sooner after a fire in that 1 year sampling point, while about 40% recovery at 8 years post-fire. So here we're seeing that seed bank recovery increases with time since fire as expected, but even 8 years post-fire, these seed banks are not fully recovered, and we've heard a lot about that today as well. So not super surprising, but what's good to know here is that these indicate that these might be areas where we could do active restoration, especially in the face of more frequent fires. We also found that there was less variable recovery on south aspects, and this variability is really important since it provides a chance of having higher recovery, such as when conditions are suitable for high reproduction like in wet years. And since these south aspects lack this variability, they may need more active restoration than north-facing aspects. So now that we've seen that the south aspects might be at risk for lower seed bank recovery and need active restoration, we wanted to then test some different restoration methods, specifically relating to how time since fire and trait-based communities influence our restoration planting success. So we planted at both of these sites in the same time in winter of 2022. where the lake fire was planted 1 year post-fire and the powerhouse was planted 8 years post-fire. And these pictures on the right show what the initial planting conditions looked like, where at the powerhouse, we're at a mid-recovery point. There are still large patches of bare ground. And at the lake fire, it's at an early recovery stage, but there were still large patches of bare ground that weren't recovering or had no evidence of vegetation recovering. Okay, and then so within each of these burn scars, I established 3 treatment plots testing different functional strategies with 2 replicates each and a control to test the efficacy of doing active management compared to natural recovery in these areas. And the treatment plot species mixes were selected based on their regeneration trait values of each species, which corresponded to a functional strategy of being acquisitive, conservative, or a high diversity mix that included both species of both of the other mixes. And this table here shows the different species that were selected in each mix. And these species mixes were created with regeneration trait data, which reflect the strategies that plants have at the early establishment and survival stage when they're actually being planted for restoration. And you'll also notice here that these were mainly CSS species. We had limitations in our seed availability to actually test this with Kargul chaparral species. We planted about 1,000 shrubs into these burn scars, and these were all done on south aspects in high severity areas. And here's a picture of what the planting looked like, where we created grids of 4 different species per treatment plot, and then tagged each individual so we could track their survival. Drawing you to this figure, the x-axis is time, where we planted in winter of 2022. We surveyed for establishment in the spring, and then surveyed for summer survival in the fall, and then surveyed again at the 1 year post-planting time point the following spring. And the y-axis is survival probability. First, I want to focus on the line types, where the solid line is 1 year post-fire, and the dashed line is 8 years post-fire. And we found that planting sooner after a fire had a higher survival probability. That solid line is much higher. The overall survival was 56% in year 1, and only 8% at the 8 year post-planting. And so this really highlights the importance of restoring when post-fire conditions are suitable for establishment, such as when resources are high. Next, I want to look at the color differences, where the green is the acquisitive strategy, the blue is conservative, and the gray is diverse. Initially, we saw higher survival probability with the green acquisitive strategy during establishment and summer survival. But at the 1 year post-planting time point, we actually saw that the blue conservative strategy had a higher survival. And again, this is all on south-facing slopes. So we're seeing that the conservative, more stress-tolerant strategy may prove better for overall and long-term survival, but the acquisitive strategy was really great for early establishment, highlighting these strategies might be selected for different restoration goals, and also the general transient nature of restoration. And to summarize, we found that the seed bank recovery increases with time since fire, but it's low and slow, and that there's less variability in seed bank recovery on southwest aspects, indicating that these might be areas we should think about actively restoring. Next, we saw that planting sooner after a fire greatly improved survival and restoration success. And finally, we saw that conservative community strategies improved survival 1 year post-planting on south aspects. And so, just tying it all together, this really helps highlight the importance of time since fire on restoration, success, and seed bank recovery. Thank you.